senior design was devoid of any hardware whatsoever. So we were essentially contracted by Professor Morris to create a communication system using an iPad that could be used in a hospital environment to help bridge the gap in communication between patients and primarily nurses. The patients we were targeting were ones who suffered from stroke or were aphasic or ones who just simply couldn't or didn't speak English as well. And after talking with and having numerous meetings with nurses and doctors, we came to the conclusion that they would greatly welcome some sort of new communication system to help them bridge this gap with their patients. So I'm going to...
So our main objective is to build a wireless communication system that would help streamline request data from the patient's room to the nurse's station. Using the iPad, the patient will be able to navigate through a whole catalog of different request options, ranging from help with physical ailments to supportive care. Using a web application, requests will be processed, presented to the nurses in a way that makes it the most relevant, practical, and manageable with immediate effect. Our requirements for the system includes the fact that we need to use an iPad as the main communication device. Our iPad application has to include a GUI interface that's picture-based, and below each of these pictures includes a word description. The application itself is organized in a feel like that structure. Furthermore, the nurses must receive requests with minimal delay. The web application must prioritize requests based on predetermined urgency. So in other words, requests, say a request for a glass of water would be preset to have a lower priority ranking than say a request for help with stomach pain. The way in which the prioritizing is set is very flexible for the user's benefit. Furthermore, the system must support multiple iPads simultaneously. And lastly, the web application must be secure with login credentials. And now I'm going to hand this off to Eric, who's going to give us a Google view of the system.
So this is a overall block diagram of our system. You can see that there's really three components to this. There's the iPad, which is used by the patients. It's kind of a client device. And the iPad is used to place requests into the database, which is sitting inside of a server. And at the nurse's station, an internet browser is used to view these requests. So, and the nurses, of course, can respond to these requests and remove them from the outstanding queue. So our software, it closely follows a model view controller software design methodology. And this is a pretty influential way to tackle large-scale software products. Apple really encourages developers to follow this methodology, and our web application is going to be using the Ruby on Rails framework, and that also closely adheres to this design process. So the model is the application's data. It's really the guts of the application. It's the data that is stored and viewed by the user. And the view is actually what the user sees. So that in the iPad application, that's the GUI interface. And in our web application, that's the HTML layout. And the controller is the brains of the application. So the controller is able to intelligently react to user input and manipulate data, the model, or dynamically build a view for the user. And the value in this approach to software design is that it distinctly separates these into various sections. So it ensures atomic operation across the application, and it allows one team to be working on the model and another team to be working on the view. So if changes are made to the way that the view displays information, it doesn't change the way that the model handles data. And as a result, large projects can be managed and built over separate time zones.
The iPad application was developed in Apple's programming environment Xcode using Objective-C. All iPhone or iPad applications have to be developed on a Mac OS system. Deployed on the iPad is a library of program requests. We work with augmented care specialists, doctors, nurses to produce this library. There are already augmented care libraries out there, but they're very expensive to obtain licenses for. So we work with a graphic designer to develop our own icons. Requests vary from very basic requests, such as thirsty or hungry, to more complex requests, such as severe pain in the right shoulder. The app is intuitive for patients with limited communication ability. This allows for a very easy user experience without creating frustration with the user. The last thing you want to do is give a patient an iPad and say, use this, and confuse them. The user navigates through the system pictographically. Every time the patient hits a button, it sends them to the next level of the hierarchy structure. The hierarchy has variable depth because requests vary in detail. When the final icon is pressed, requests are sent from the iPad to the web application. And here's a picture of two of our screens. On the left, you have the home screen. On every page, you will see iCare for You and the home button screen. Below, you have emergency and family, which are two requests already. And below that, you have pain, bathroom, food, and comfort, which take you to different layers. We have the device information button, which Eric will talk about more in a little bit. And if you hit bathroom, it'll take you to this next slide, which gives you 7 different options that can be sent to the web application.
So just to talk about some of the iPad application components, the way that this variable view hierarchy is achieved is that there's a primary view controller that has references to a number of different subviews. So if you look at the screen on the left-hand side, that's the home screen. That's managed by the primary view controller, so this is the top-level screen. And if I were to hit one of these categories, it would shift me into the bathroom subview. So there's a primary controller, and it contains references to 9 other subcontrollers, and these subcontrollers present the user these deeper views. So the primary controller really kind of acts as a dispatcher, if you will, or will switch in and out views depending on what the user has decided they'd like to do. And so for thinking about future development, we decided to use a property list-based model. So a property list is essentially, you could look at it like an Excel spreadsheet. In reality, it's actually an array of dictionaries. And in each of these dictionaries, we have a request and an urgency. And that request can be set by the developer. So if you'd like to add a new request to the structure, it's as easy as adding a new dictionary into this array and attaching your request and your urgency to that dictionary element. And this is all done through Apple's Xcode. It's a really easy editor environment that you can pull up and edit. And this property list is essentially the model of our overall system, and it's loaded into the primary controller. So the controller, when a button is pressed, each button has a tag associated with it, and it uses this numbered tag. It's just an integer to index into the array, pull out the information from the dictionary, and to package up a request object to be sent to the web application. So if you actually take a look at the bottom of the left-hand screen, there's a device information button. What that displays to the user is the iPad's identification number, which is unique to every iPad. And so the way that our system handles multiple iPads is that it takes in this, you can pull up the screen in the web application and assign a patient and a room number to that specific device. And you can remove that as well. So you can remove this association with an individual patient. That way we can have a variable amount of iPads associated with the entire system. And finally, we have status alerts. So when a request is made, pop-up similar to when you get a text message on an iPhone, alerts you whether or not the request has been successfully sent to the web server.
So I'm going to talk about the web application for a little bit, and what we had to come up with was a way to efficiently display all of the new requests. And the way it does this is by polling the server at a specific interval, and that interval is actually 10 seconds. Not only does our web app hold all of the requests, but it also comprises itself of different pages that holds the relevant information to what nurses are attached to the system and who has access to the system, as well as what iPads are registered to which patients. So it's a way to manage all of the information essentially in one place for this whole system. Like we said earlier, the web app is platform independent, meaning that it can be run on a Mac or a Windows, Linux, Internet Explorer, Firefox. It doesn't make a difference. It's just like going to any other web page. You just pull up a browser and you enter in the address. When we first started this project, we kind of had to think about, did we want to do a web app, or did we want to come up with some sort of custom device? And we settled on using a web app due to the fact that a custom device would add clutter, would add something else to the nurse's station, and we didn't know what was already there or what we could add or couldn't add and how that would affect their jobs already. So we felt that the web app would be the easiest to access and it would be the easiest to understand. It doesn't need any sort of technical background. It's just using the internet. And we thought this would be the best way to help the nurses organize, prioritize, and manage all of the incoming requests in an efficient way. So, as we talked about earlier, the web application's main page has a table there which consists of the following fields, as you can see: patient name, room number, created at, which is a timestamp for when the request was transmitted by the patient, and of course the request. We also have two other columns in this table. One is urgency, which notifies the nurses how important the call is. All of these are predetermined that we set, but they are variable. They rank from 1 to 10, except for, as you saw before on the home page, the emergency button is preset to 11. Again, after talking with a bunch of nurses and doctors, we found out that sometimes patients just need, just like the call button that already exists, a general help button. So the emergency one is there for patients who need they don't have time to put in words what they have, or sometimes when nurses arrive at a room, not knowing what to expect, they sometimes need a little extra help, and this is another way for them to call for more help as well. The last column is request count. Now, the importance of this is to essentially get rid of the amount of the viewed requests on the web app. What this does is it takes a tally and a counter of how many times the same exact request has been posted by the same patient. So instead of one guy sitting there and keeps pressing, I'm thirsty, I'm thirsty, I'm thirsty 50 times and 50 different requests coming up, it just comes up once, and in the count column, it has 50. So the nurses can use this to see which patient hasn't been attended to or who's really cranky. So we have a couple other pages. The user register page is essentially for hospital administrators to give access to this system to different nurses by setting up a username and password. Again, once the nurse has a username and password, they're free to access any part of the system. The user listing page just is a page of all of the registered nurses. So it's a way to keep track of who has essentially who's allowed access to this system. Similar to the previous page, the iPad register page is a page of all of the iPads that are currently registered to which patients. And the register page helps you register an iPad with a patient. And the listing page lists again which iPads are assigned to which patients as a means to keep track of everything.
So our web application has several additional functionalities. These include login credentials, a search bar, and automatic refresh. The login credentials requires the nurse to have both a username and a password before being able to access the web app. The username is simply an email address, and the password is self-assigned to the nurse. The search bar will allow the nurse to filter through the entire request table by simply entering specific keywords into the search field. The purpose of an automatic refresh is actually to update new requests into the data table, and the page itself is automatically set to reload after every 10-second interval. The data fields on the data table are also sortable. The table itself is dynamic, so it could be reordered depending on how the nurse sees fit. So So, for example, data fields such as patient names, room numbers, or timestamps could all be chronologically, sequentially, or alphabetically ordered simply by clicking on the column header at the top of the table. As for data management, nurses can actually delete requests after attending to them or after a patient has been discharged. The deleted requests can be relayed and stored into a separate file for later analysis or usage. This all exemplifies the main value of our product, which that lies in information management utility. This is basically what our finalized version of the request page looks like. And as you can see from the down arrow next to the word urgency, the table in the screenshot is actually sorting everything by the urgency priority. And that's our presentation.
The image you just showed looks remarkably like the Twinkie environment. Is that the backend for your web?
No, we use the Ruby on Rails framework.
Oh, okay. Use Ruby
Yeah.
on Rails.
So that's actually just an HTML table right there. Yeah.
And when it refreshes, does it reset the order rate?
No, so it sorts by urgency by default, but when the page is reloaded, but you can filter the results by clicking on the column headers.
Right, but if it refreshes every 10 seconds and I click on request count and then 3 seconds later it refreshes, will you get me back?
Yeah. So that's what you're sorting is stored in a state variable. So when it reloads the page, that variable isn't reset. So it maintains that.
Have you tried it all with your customers at the hospital, or is that a future story?
Yeah, it's actually, so the project is actually being carried on by a few engineers over the summer, and they're currently in the process of having this demoed in Mass General Hospital. So we're working closely with the neurology group there.
So in order to update the information, you're refreshing the whole page. You're sending a request to the server to refresh the whole page. How come you haven't used technology like Ajax or something like that to?
Yeah,
to
so that's something that. So we did a lot of research into how to effectively reload this page, and obviously reloading the entire page isn't necessarily the best way to go about that.
Yeah.
We really just ran out of time. It was something that none of us were really familiar with JavaScript or Ajax scripting. So Ajax scripting, for those of you who don't know, is it essentially is making asynchronous requests to the server. So without reloading entire pieces of web pages, you can actually, it would just simply grab new comments that are brand new and render them dynamically into the page without refreshing the entire page and making the request to the server. But that was just something that we weren't able to implement, and that's obviously immediately on our minds for the next version of the project. Good.
What was the reaction from the hospital to the idea of having several hundred, $500 iPads handed out to patients who might throw them, vomit on them? They're expensive things to hand out to sick people.
Yeah, most devices in hospitals are actually far more expensive than $500. So they weren't actually, their concern wasn't with the price or the damage to said device. It was more of a question of essentially how useful will this be and how much the cost and net benefit of it, in the sense of if we include this, will it really affect any sort of people, or is it just going to be a marginal difference?
They were really, I think they were really concerned with, I mean, there's a lot of stuff going on in hospitals at any given time, and they really wanted to kind of minimize the impact of adding a whole other device, because a lot of people would just kind of look at it as, oh, I have to learn another piece of technology, and that's really kind of a hassle for, especially in a hectic environment like that. So, which is part of the reason why we decided to go with a web application versus a custom piece of hardware that's sitting at the nurse's station, and they really liked that idea. But more to your question, down the road, they're actually, Professor Morse is here, and he's considering fabricating actually a new device that less, costs less, and is easier to clean. Actually, that was another thing that we were concerned with was keeping these things sterile, because obviously everything has to be sterile in an acute care environment.
John?
I had a stroke when I came back from China, and I was unable to speak a word. And that experience is what has led me to this device.
So my question is, you mentioned that if somebody makes a request and there isn't successful intervention,
Correct.
right? So what
It'll
happens-
explain why. So usually, the only two cases that I think that the only two cases we prepare for would be is the iPad not connected to the wireless and is the server down. And in both cases, the pop-up notifies the user of which case that is.
So what happens in the emergency case?
So the other thing about this tool is it's an additional tool. It's not strictly the only thing this is not intended to replace the call bell system. So there is a fallback that it's just it's kind of a way to add additional information for both the patients and for the nurses. So there is this is never intended to be the only system that's sitting inside of the room. There's also a call bell.
I guess going along that same thread, if you make a request, does the nurse have the ability to acknowledge that request so they don't keep hitting the same button and you're ignoring?
No. Yes and no. The way they acknowledge that request is by attending to it. Do they have a way to communicate back to the patient that your request is being attended to? Not in this version of the project.
The nurses be able to access this on their own iPad, like if they're walking around?
Yes.
And on even a smartphone.
Yeah, anything that can open up a web browser.
Is it in the ward this is being tested in? Are there multiple nurses stations or just one?
They're actually moving to MGH is moving their neurological ward to another part of the building, and it was actually just recently built. Previously, it was kind of in the shape of an H, so with the nurses station in the center, and that actually proved to be a hassle because just the way that there are better ways to form the ward if you need to run across to get to another part of the ward. So their new structure is actually kind of in the shape of a bike wheel with the spokes being like more wings, and the nurses station is centered in the middle. So there was one in this particular ward, but it's possible that there are multiple stations.
What kind of security do you have built in so that a random person just doesn't log in on the smartphone?
So we have currently you have to authenticate into this system. So there's a login screen, and you can see in the upper left-hand corner that it tells you that you're logged in and you have the ability to log out. And the way that it maintains that is by creating a session. So you won't be able to just simply type in the URL to the request screen because it verifies against that cookie, and it requires authentication. So if you try and do that, it'll bounce you back to the initial screen. And this is all supported by the Ruby on Rails framework. So you can't tamper with a cookie because Rails won't load it. So it's pretty secure in that aspect.
If a user makes a request, are they allowed to make that request and say they have an issue?
Not currently, no.
So if my room number was 12A, I could crash your web server?
Sorry?
If your room numbers are in floats, so if my room number was a string.
We tested that with you at our last test.
That's right.
Yeah, it's not a problem. So if you had a 12A,
We'd say 12A.
Okay. Your display is not.
Yeah, it's currently displayed in the float. But if you were to put in a string, it doesn't. We can demo that for you.
I actually have a more important question. Is there any liability issue with the nurse not getting back to the patient? in time?
Yeah, so we had that discussion with, we were at the Children's Hospital actually, and that was one of the questions that we asked of, there's a doctor there, his name's John Costello, and he's been working this field for about 25 years, I think he had said, so he's been doing this for quite a long time. And he's actually working on a similar application to this, so he actually wasn't able to give us much advice on developing the application, but we were able to ask him some liability questions, and he was talking about how essentially, unless this device is marketed as specifically the device, the designated device for the room, then we would be responsible, and we'd have to follow some of the, there are certain hospital codes that hospitals need to adhere to get federal funding. But because this isn't the only device in the room, and there is, the call bell is the one that is really the distinct designated emergency button. So the liability isn't as high because it's not the designated communication tool.
All right, thank you.
I have one more. You mentioned the H or circular ward design. Can you have communication leakage to the next floor? And does that have implications for how you configure a system in a multi-floor facility?
So these requests are being made over the HTTP protocol, so it's similar to how you would access any website just in a regular browser. So there's no communication leakage or interference as we understand it.